Hello, students.
Hello, teacher.
How are you today?
We are fine, and you?
I am fine. Today, we are going to learn about energy band in solids. Okay?
Yes.
And the solid which we are going to talk about is conductor, insulator, and semiconductor. Now, who can give us example of conductor? Yes, Asha?
Copper.
Copper, good. 3 claps for her. Another? Muhammad?
Iron.
Iron, good. 3 claps for her. Another? Yes?
Silver.
Silver, good. 3 claps for her. Now, insulators. Who can give us example of insulator? Yes?
Plastic.
Plastic, good. 3 claps for him. Another example? Yes?
Wood.
Wood, 3 claps for him. Yes?
Rubber.
Rubber, good. 3 claps for her. Now, it is a time for a semiconductor. Example of a semiconductor? Yes?
Silicon.
Silicon, good. 3 claps for him. Another? Yes?
Carbon.
Carbon, very good. 3 claps for him. Another one? Yes? Antimony, very good. 3 claps for her. Students, we are going to play a role play about conductor, insulator, and semiconductor. Are you ready?
Yes.
Okay. I need 4 students to come forward. Now we are going to play a role play about a conductor, movement of electrons from valence band to conduction band. Okay? Yes. So now, electron. We have seen that electron is able to move from conduction band to conduction band, from valence band to conduction band. This means that the conductor now can conduct electricity. Okay?
Yes.
After that, we are going to play a role play about insulator. Student, you are going to watch about the movement of electron from valence band to conduction band if it is able to reach the conduction band. Now electron, we have observed that the electron didn't manage to reach the conduction band. This means that insulator cannot allow electricity to pass through it. Okay?
Yes.
Okay? Now we are going to play a role play about semiconductor. Also, we will see how the electron will manage to reach conduction band, if it is going to manage or not. Okay, electron? We have observed that electron was able to reach conduction band, but by using high force. Okay? Yeah. So now in this case, semiconductor can allow few electrons to get into conduction band, therefore can allow electricity to pass, but not as much as conductor. Okay?
Yes.
Okay, thank you very much. Now we can go back to sit on our benches. Students, now what have you observed? What is the difference between conductor, insulator, and semiconductor in terms of their energy bands? What is the difference? How can you differentiate? How can you distinguish conductor, semiconductor, and insulator according to their energy band? You compare those energy bands. That, can you?
Yes. Conductor, when it is passed through to the conductor, electron when want to pass through to the conductor, it has a small gap.
Small gap.
Yeah, while electron, when it want to pass through to the insulator, the valence band and the conduction band have a big gap.
So,
And semiconductor, electron when want to move to the conductor, the insulator, the valence band and the conduction band, and it just close, but the electron it move for using high force to the conductor.
good try. Who can explain again? Who can try to explain more?
Conductor is a material that can use it to flow electricity, but insulator is a material that does not flow electricity, and semiconductor is a material that allows electricity to flow but for more effort.
Very good. Clap for her. Okay, another question is, you are asked to differentiate or to distinguish between conductor, semiconductor, and insulator according to their energy bands. How can you give differences between these three by using the energy bands which we are seeing? You had in a conductor, we see the energy bands, how valence and the conduction bands, how we are there. In insulator we saw, in semiconductor also we saw. Now how can you differentiate these three things by using these energy bands? That means if you are differentiating by using, you have to say in a conductor energy bands are like this, in insulator energy band are like this, in semiconductor energy band are like this. That is how to differentiate or to distinguish it. Who can do that? No one. Okay? Yes? Yeah. Welcome.
In a conductor energy band, there is no energy band in a conductor because there is no distance between the electron and another. But in a insulator, the energy band have the long distance. And about the semiconductor energy band, it is between the electron and connect and the insulator.
Okay. A good try. 2 claps for her. Okay. The difference is, as she has said, in a conductor, conduction band and valence band overlap. This makes easier an electron to move from valence band to conduction band. Okay? In insulator, there is a big gap between valence band and the conduction band. We have the so-called forbidden gap. It is not easier for an electron to jump from valence band to conduction band. Therefore, insulator cannot allow electricity to pass through because the electron cannot reach there. In a semiconductor now, the distance between valence band and the conduction band are a little bit small, okay? Now this one, by more effort, more energy, electron can jump from valence band to conduction band. Therefore, a semiconductor can allow electric current to pass through, not as much as that of a conductor. That's why we can say it is a semi, means halfway. Okay?
Yes.
Who can tell us the difference between insulator, semiconductor, and the conductor using the energy bands? Asha?
In a conductor, the energy band does not react, but in insulator, the energy band is be high, while in a semiconductor, the energy band will be not high, will be between the insulator and electron.
So we can see this is the conduction band, okay, and this is the valence band, valence band. So we can see now here there is overlap. There is overlap here. We call it overlapping, overlap of conduction band, because they are overlapping. Therefore, the distance is very small. Therefore, electron can jump from here to here very easy. Okay?
Yes.
How about insulator? How about insulator? Who can answer? What happens in insulator, so that what happens in insulator according to the valence bands? Yes?
The insulator, the gap between conduction band and valence band is big.
Is big. So we can have this one. Very good. Clap for her. So this is the band gap, and here is the valence band, and here is the conduction band. Therefore, electron is here, electron. Because the gap is very large, the electron cannot jump to conduction band. In that case, insulator cannot allow electric current to pass through, because the electron cannot jump to the conduction band. Okay?
Yes.
How about in semiconductor? Who can tell us? Who can tell us about semiconductor? Can you try? Okay, you want to repeat? Thank you very much. In insulate, in semiconductor.
In a semiconductor, the conduction band and valence band are squeezed together.
Are you sure they are squeezed together?
Yes, and they have a small space.
How can you differentiate them with the conductor? Because we say in the conductor, they overlap. Valence band and the conduction band, they overlap together. There is no distance between valence band and the conduction band. But how about in the semiconductor? How they arrange this one? Are they really squeezed together?
They have a small space.
Small space, small distance, small bands. Good, clap for her. So here, we can have valence band here, and we can have, this is the distance, very small, okay? Very small. Here we have conduction band, and we have valence band. So with much energy, electron can jump from valence band, can cross this gap, and become in a conduction band. Therefore, semiconductor can allow few current to pass through, not as much as in conductor. Because of this gap here, it needs some energy to push an electron to jump this gap so that it can be there to conduct electricity. Okay?
Yes.
So now, what is conductor?
Conductor is the material which allows the electricity to pass through.
Okay, good. Clap for him. Which allow electricity to pass through it. Good. What is insulator? Yes.
insulator is a material which does not allow electricity to pass through.
Very good. Clap for her, 3 claps. So you can say is a material which does not allow electricity to pass through it. Good. How about semiconductor? Yes?
Semiconductor is a material between semiconductor and insulator.
Is it true?
Yes.
Why do you say is a material between? What do you mean when you say is a material between?
Between insulator.
That you mean that that is semiconductor is between. What do you mean by that? Yes?
Material.
Is a material, huh? Continue.
Which allow electricity to conductor and insulator.
Okay, good try. Sit down. Yes?
In a material which allow electricity to flow in few by using high force.
By using high force. Good. Clap for him. So we say semiconductor is a material. Is a material in which conduction of electricity is between that of conductor and insulator. Thank you very much. Have we understood all of us?
Yes.
No question?
No question.
Thank you very much for participating in this lesson, and I hope those who have watched our lesson have enjoyed with the lesson. Thank you very much. That is the end of our lesson for today.